Hello everyone and welcome to this video where we will be solving problems about resistance. The resistance of a copper wire depends on the length of the wire, the temperature of the wire, the type of insulation covering the wire. So I think it's very clear that the answer will be, in this case, 1 and 2, which is B, because the insulation covering the wire doesn't have to do with the three factors we learned about. The three factors were the length, the temperature, and the cross-sectional area. Question number 2. If we double the resistance and triple the potential difference, the current will be 1.5 ampere, 1 ampere, 0.75, 2 over 3 ampere. Well, to solve these types of problems, we said that we will be facing these types of problems a lot. We are asked about the current. We know that we can create this small, simple triangle that shows us the relationship between resistance, current, and potential difference. We know that the potential difference is and here we can put the current, and here we can put the resistance. Okay, so if we want the current, it will be the potential difference divided by the resistance. So I, which is the current, is equal to the potential difference, delta V, divided by R. Okay, now we know that the resistance is doubled. If we know that we double the resistance and we triple the potential difference. So we can say now that let's call this I1. Now I2 is when we change the potential difference and the resistance, we double the resistance and we triple the potential difference. So we can say that is 3 multiplied by delta V divided by 2 multiplied by R, because we doubled the resistance, right? So I2 will be 3 multiplied by the potential difference divided by 2 multiplied by the resistance. Okay, we know that delta V over R is equal to I1, which is the first case before doubling and tripling the resistance and potential difference. So we can say the following: I2 will be equal to 3 over 2 multiplied by I1. So if we compare I2 to I1, we see that it is 3 over 2 I1, which is equal to 1.5. So the answer is clearly A. Question number 3. The circuit shown has a wire made of 3 segments. They all have the same length, but different cross-sectional areas and are made from the same material. So we see that we have the same material, so we are controlling the parameters here, and they have the same length. So the only thing that is different here is the cross-sectional area. And we know the relationship between the resistance and cross-sectional area is the larger the cross-sectional area, the lower the resistance is. So which one of these choices describes the currents in the segment? So it's asking about the current. We know, once again, that I, which is the current, is delta V divided by R. Okay, so we know that each one of these has a different resistance. We know that the relationship between the current and the resistance is inversely proportional. Okay, so we can say the following: that 3 has the thinnest cross-sectional area, so it has the highest resistance. So 3 has the highest resistance. Then comes 1, which is clear. Then comes 2. Since 3 has the highest resistance, it will have the lowest current. So number 1, this will have the highest current. Then this will have the second highest current. And this will have the third highest current. If we look at the choices, it is clear that this is the right answer right here. Okay, because the current is in highest in 2, and then in section number 1, and then in section number 3. The next question: which one of these segments describes the resistance of the segments? Which one has the highest resistance? It's clear that 3 has the highest resistance, then comes 1, then comes 2. So the answer is clear, which is A. Next question: the current in a resistor is 1 ampere. If the potential difference was tripled, the current will be, again, it's asking about the current, so we can say the following: I is equal to delta V over R. And let's call this I1. Now, in this case, I1 is equal to 1 amperes, correct? Now, it's asking what will happen if the potential difference was tripled. So I2 is equal to delta V, or let's say 3 delta V because the potential difference was tripled, but the resistance remained the same. And we know that delta V over R, it's clear that it is I1. So we can say that I2 is equal to 3I1. And we learned from the question that I1 is equal to 1 ampere. So we can say that I2 is equal to 3 multiplied by 1, which is equal to 3 amperes. So the answer is C. When a circuit consisting of a battery with a potential difference equal to V and resistance equal to R, the current was equal to I. What will the current be if the battery was changed to 5V and the resistance became 2.5R? I think it became very easy now. Let's call this I1, which is delta V over R. And let's call this I2, where delta V became 5 delta Vs and R became 2.5 R. And we can just simply replace this with I1, and we can say that I2 is equal to 5 divided by 2.5 I1, which is equal to 2I1. So the answer is B. It's clear that it is 2I. The device that can be added to increase or decrease the volume in a car's radio, actually it's pretty clear. It's a variable resistor because we can control the resistor with a variable resistor. What is the potential difference needed for a battery on a circuit to allow for 15 columns to pass each second, knowing that it has a resistor equal to 5 ohms? Okay, it's asking about the potential difference, right? The potential difference, delta V, is equal to I multiplied by R. Okay, now we see that we have the resistance, which is 5 ohms, but we do not have the current right here. But we have another piece of information that says that we have 15 columns passing each second. And we know that the current is equal to number of charges divided by time. So we can say that the current is equal to 15 amperes. And we can simply go back to our question. 15 multiplied by 5, which is equal to 75 volts. And the answer is B. I hope this makes resistance much easier and much more clear. Stay tuned in the next videos. We will be going more in details in circuits.